Hello, so this is actually the end of the video, and by the end of this video you're going to have something like this. I would apologise for taking so long with the particles thing, but it's my life, I'll do what I want with it. I'm just messing. I'm genuinely sorry it's taken me so long to put together. It's actually been a bit of a nightmare, but it'll be worth watching the whole thing. It's quite long, it's about 40 minutes, but by the end of it you'll have a good particle system together and we can start moving on to something else like compute shaders or something like that. I don't know, we'll see how it goes. I might end up doing another little video on the particles, just to kind of add to buffers and stuff like that. Anyway, I'm going to leave you to it. I hope you enjoy. Some rubbish intro, but yeah, good luck. Hello. So, you wouldn't believe how many times I've tried to make this video. Let's get on with this particle stuff then. I'm just going to go to the GitHub and get the project. Sorry, I'm in a bit of a mood because it never seems to go the way I want it to. Oh god, I put a space in and everything. It's not going to find me, is it? There we go. I'm going to stop being in the mood now and we'll be happy fun time OpenGL stuff. So hopefully you followed along there. Simply search for me and then I went to users and going to go to OpenGL template and download the zip. And we'll open it up in the folder and then extract it here. Hopefully you've seen how to set up this. Anyway, so this particles has not gone well so far, but this time I am determined for this video to be finished. The reason it's not going well is because there's a lot more to it than I thought. If I remember right, the last thing I said was that this will be easier because we're making things from scratch. And in some sense that's true, but it is going to be a little bit more to take in this time because we're going into deeper territory basically with OpenGL. So right, so I've loaded up the project, I need to go to 86, make sure the OpenGL toolkit, not the experimental one, is loaded. Oh, for God's sake, I click build. Simply control pause break if you want to cancel a build. You don't need to build every single time. Make sure it's set as the startup project by clicking on that. It should be already, you know, but just in case. Now I'm going to run it. Should get a nice blue triangle. And we have a blue triangle. So, particles. Let's get rid of everything we don't want, which is literally all of this. The only thing we're including in here is glad GLFW in the IO stream. We don't really need the IO stream, but we can leave it in there anyway. What we need to include is, actually we need to put a speech marks for this bit, and ... to go up a level, and then we need to go to template. Window, and that's the window included. We need to set the window, so window, and then int main for the main function, and then window dot initialize while window dot get window should close equals false, and I'll run it. We'll get a nice big, tiny window actually because it's 400 by 400 pixels for the default one, and when we press escape it doesn't close. So just going to close that and get some stuff set up. So the window, we actually want it to be the window size, so window 1920 by 1080, there's the size of my window, and then when it initializes it'll be now nice and big. And GLFW poll events is a thing with GLFW so that when you press escape now, the window will close. So nice big window, escape closes the window. Cool. Oops, I accidentally done that. Now window.swap buffers because we're using double buffering, and finally we need to set up OpenGL. So we've done GLFW, and if you're wondering why GLFW doesn't work when we use 64-bit, it's because GLFW's libraries and binaries are in 32-bit, so it's this version, there is a 64-bit version, but I'm not using it, and I've run into problems with it. So yeah, we're using the 32-bit version. And if I remember right, the only reason it doesn't work in 64-bit is because 64-bit pointers are 8 bytes and 32-bit pointers are 4 bytes. Anyway, let's do some GL stuff. GL clear. We need to clear the GL color buffer bits, and that's basically the buffer that's storing all the data for the screen for color. So every single pixel every single pixel is going to be cleared to the same color, and the color we want that to be is actually, what happens if we just leave it like that? What's it going to look like? It's just black. That's boring. GL clear color. We want to set this to green so we know it's working. Run it again, and nice, it's green. Let's change this so it's an almost black color. We don't want it to be fully black, because if you have a fully black window and you render and you can't see the black object on a black background, wait, that made no sense. Basically, if you render with a completely black background, you're having problems rendering and the colors being set to 0 for some reason, then you won't be able to see it because it'll be black on a black background. So there we go, we've got a grey color. I'll do. I don't like it, but whatever. So let's make these particles then. We're going to prototype the class using a header and a CPP file, and I'll show you how it's going to be modular. We'll simply include it into another OpenGL toolkit and then use it. Simple as that, just to kind of show how modular it is. But for now, let's just make it. So right click on the OpenGL toolkit, add class. I'm going to name this particles with a capital P. It's the same as we've done with the window over here. You can see that it's a higher, uppercase W for the window there, and then a lowercase w for the window on the there. And that's basically the class concept, which is green, and then the window is actually the object, as in the class instanced. So we're going to do the same thing with particles. But anyway, let's click OK. And what OpenGL, what Visual Studio has done, even if we go into the template, hello. Where has it gone? It's not in the template, sorry, it's in the actual project, which is OpenGL Toolkit. There is where it's created these two files, the CPP and the .h file. So the CPP file is including literally just particles.h, and then the particles.h doesn't include anything, it's just got pragma once, which means it gets included once. And then you got a very, very basic class template. So let's start filling this up. We want public, and we want to be able to create particles, so a void function to create particles, and we want a void function to render the particles, and we also want some private stuff, so private, and we want GLUint for the particle object location. I'll explain what this is in a minute, and GLUint for the number of particles, if I could type. Oh, we don't have access to any of this stuff, so let's just quickly include those as well. So underneath the pragma once, include, we want a vector to be able to store, use even, dynamic arrays. We want, what else do we want? We want random, so we can add random data to particles, and the glad header, so that we can have access to GL functions, types, and variables. And that gets rid of the GLUint bit. Only glad gets rid of that. I'll explain what vector is in a moment, and random when we use it. I don't know if I'll use it at all, but I'll leave it there anyway, because when I was trying to write this this tutorial, I did use random because it was nice, but we're going to improvise this and see how it goes. Hopefully this will be the last time I deal with it. I've rewritten this tutorial 5 times, I think. I'm so tired of it that I'm literally just going to go through it, and hopefully you guys learn a nice amount of stuff. And I can kind of promise that, because I do go into a lot of detail. So let's highlight these two. Right click, quick actions and refactorings, create declaration / definition, and they're no longer green and squiggly. You can see down here it says Lewis downloads template blah blah blah, that it's created something successfully. If we go over to the CPP file, that's basically what it's done. It's created these functions but not filled them out. And what we've done here is basically create a class prototype. And maybe you're wondering what the point of a CPP file is and a .h file is. We could simply cut this out and paste it underneath if we wanted, but what this does is just make this file larger than it needs to be, but I don't know how to put it. So the header file is basically like looking at it from a high view, like this isn't going to get any bigger really, and we can simply see it creates particles, it renders, and what kind of private variables it's got. And then in the CPP file, we're going to fill this out with the functions, and it's basically the nitty-gritty details that we don't need to know about these functions. So this is like a design choice more than anything else. It's just so that it's nice and simple for us to use as coders. So this is the class prototype, which means it's kind of got everything in it that we need so far, that we believe we need anyway. It's like a design, and prototype basically means it's there, but it has no function yet. So let's just finish off prototyping this by including it into the main. So particles, which is basically looking in the project folder for the particles.h. And we need to create an instance, particles. I'm going to lowercase particles for the second bit. Particles down here, we want to go down to window. After window initialize, create particles. And then finally, particles.render. Now, I know I'm rushing through. I won't keep rushing through anymore because we're going to actually start talking about what this is doing with OpenGL. I just wanted to rush this bit because this video is going to be quite long anyway. I really wanted to try and get this done in less than 20 minutes, but that doesn't seem possible. It's probably going to be like 40 minutes, maybe even well, maybe even longer. We'll just see. We'll see how it goes. So that's our class prototype. Let's start filling out stuff. The first thing I'm going to fill out, because it's nice and simple, is the render function, and it gives me a chance to talk about what a vertex array object is, which you haven't actually heard of yet. So if I say gl bind vertex array and put in the particle object location, you're not going to understand anything that's just happened, but that's why I'm making the video. So bind vertex array, what a vertex array is what OpenGL is expecting you to pass into this kind of function, but it doesn't really make sense for what we're using it for. So I've kind of renamed it to particle object location. Now this object location is going to be in the graphics card memory, and it's basically like the class. It's just an object in memory, and we're basically making it the most active one, well, the active object to talk to. So we can say, because we have no control over the graphics card memory from the memory we're using right now, which is the CPU memory, we're basically the only communication we've got is by telling OpenGL what to do. So this is basically making the, God, if I say basically one more time, this is making the particle object the active object to talk to, and what we want OpenGL to do with that object is draw. God, that's the longest way of getting to that point. GL points specifically. GL points are basically points on the screen, so they're going to be pixels, but we can change the size of a point to like 5 pixels, 10 pixels, whatever, and we can do it inside the shader as well, which is quite cool. Makes things nice and random. So we want the first, which is going to be 0, the last, which is going to be the number of particles, and that's that done. And then we simply bind vertex array 0 on the end there, so that we make the particle object not active anymore, and it's nice and clean. It's basically like saying we're not talking to you anymore. So that's that bit done, and I know I went a bit weird with this vertex array object, but don't worry, we're going to make more sense of it, because we're going to actually start we're going to start filling out buffers and stuff and attaching it to that object, which is basically like attaching these two to a private member of a particle. We don't actually talk to these private variables from anywhere else but inside particles. So when we attach a buffer to a vertex array object, like here, I'll tell you what, I'll talk about it more when we actually start filling out the buffers. For now, we're going to start using the... Oh, actually, I've just realized I've missed something, which is we've got the create particles function here, but we want to set how many particles we want. So I'm going to set 1,000 there, and then go over to create particles function in the particles.h, and I'm going to say gl uint number of particles in, and just going to copy this whole thing because we need to change this in the particles.cpp as well. And do that, and then we can say number of particles equals number of particles in, and then underneath this we need an std vector of type gl float, and this is going to be particle position data. Now maybe you're wondering what a vector is. A vector is basically a dynamic array. If you remember from the previous video, we set up a square, and we set up a static array for the data for the square. If I open up the template, and I can quickly walk you through this. So I'm going to go to template, go to the mesh, I'm going to drag it over here, and this is simply going to add it onto the tabs. It's not actually including this into the project. And then we go to the create triangle function. We can see here we got the XYZ and the UV data. This is the static array, and if we were to close this off, oops, I wasn't supposed to actually get rid of the 0. Close this off like this. Oh my god, I got rid of the 0 again. If I close this off like this, you can see how well, basically, this is how OpenGL sees the data we send to it for the cube, or the square, sorry. How is OpenGL supposed to know that these first 5 pieces of data are one position in space? It makes no sense, does it? So the reason we lay it out like this when we're doing it manually is because it just makes it nice and easy for us to see. And then when we go down to the actual create mesh function, you can see there's loads of complicated stuff going on. And we're going to write some of this, but not as complex as this. Don't worry, it's going to actually be simpler. And the reason I was talking about these, gosh, if I've lost the, there we go. The reason I was talking about this static array is because the vector can be dynamic. We can add to this, we can take away from it, we can reorganize it, and we basically want to be able to organize this in a way that we know how to decode, and then tell OpenGL how to decode that information. So let's start doing that. The first thing we need to do is make sure that every single particle we send to the well, every single particle has a position that's inside the parameters of the screen. Now, if I open up Paint, this is going to get very confusing for some of you. We've got, say this is the window, we're just going to draw an awful box for the window, and every single position on this box has to be between -1 and +1, and that might sound a bit strange for 3D and stuff because we have 3D positions for all over the world, but that's actually translated into -1 for on the x-axis, +1 there for the x-axis as well, and then +1 on the y-axis, and negative, oh my god, +1 on the y-axis, and then -1 on the y-axis there as well. The z-axis is also positive, negative, but it doesn't really have much effect on the way things look when it's translated into this screen space. And so we need to transform this number of particles, which is going to be a particle from 0 to 1,000, into a value from -1 to +1 for both the x and y positions. And one way to do that is to create a thing that I've called a minimizer in my notes, but to be honest, I don't actually know what to call this. I'm just going to call it minimizer because that's exactly what it's doing. Minimizer equals 2.0f times, divided by number of particles. And that's basically, I'm going to space these out a bit. That's basically turning, if we've got 1,000 particles coming in, this minimizer is going to be a 500th of that. So 2 divided by 1,000 is 0.02, I think. Calc 0.02 times 1,000 should be 1. It's not. It's 20. It should be 2. Oh, 0.002, sorry. 0.002 times 1,000 is going to be 2. And that's basically, we're going to say -1 plus, I'll tell you what, I'll just do it. For size t, I equals 0, I is less than the number of particles, I plus plus. So while I is iterating round in this loop, we're going to say particle position data dot pushback -1.0f, because it needs to be a float type parameter, plus I times minimizer. So say we're on the 400th iteration of this array. When we times when we put I times the minimizer, 400 times 0.002 becomes 0.8. So -1 plus 0.8 equals -0.2. Is that right? Yeah, that's right. And that's the x position, basically. Hopefully that makes a bit of sense. For the y position, I was going to do a bit of random stuff, but I think I might just... Can I use a sine function? I can. I think I might just put I times minimizer here, and that's going to make it into a nice wave, hopefully. We'll find out in a bit. It's going to be a bit of a mess otherwise. I might have to change it later on, but we'll find out. So this is the particle position data sorted out, kind of. We'll probably end up with a nasty looking thing, but for now this'll do. Now I can start talking about the vertex array object that I explained earlier. So gen vertex arrays, we want to generate one array, and we're going to say particle object location. So we're making, oops, and I forgot the ampersand, because we need to pass this value into this function, and the function is going to set this to, like, I don't know, 0 to 1,000. I have no idea what number it's going to give it, but basically that number is going to be that location in memory that this object exists, and that's on the graphics card memory, not on the CPU memory. So we're going to generate a vertex array object, and we need to bind it, so it's the active one we're talking to. So bind vertex array. We want to bind the particle object location. Now that that exists in memory, this bit makes a bit more sense because we bind the active object. We tell it to draw with the active object parameters, and then unbind it. And then, so we bound the vertex array object. Now we need to set some, assign the particle position data. Now this has to be done in buffers. So if we say gl gen buffers 1 and we need to actually have a gl uint for the buffer. So I'm going to call this the particle position buffer location, and again this is going to be the location in memory, but once we've assigned it to this object we don't need to remember it because it's going to be attached to the object. It'll be deleted when that object gets deleted as well. So gen the buffer, gl bind the buffer. We need to bind the active buffer. You have to set the target for this, so gl array buffer, and it's going to be the particle position buffer location. I know this isn't going to make much sense, but it will do at this point, I promise. Right, so gl buffer data, we want gl array buffer, and I'll explain all this in a minute. Size has to be the size in bytes, so it's the particle position data dot size, times the size of a gl float, because that's the type of data it's containing, which will give us, if there's 1,000 pieces of data, we've got 1,000 particles, we've got a position for the x and a position for the y, so 1,000 times 2 is 2,000, and then the size of a float is 4 bytes, so that's 2,000 times 4, which is 8,000 bytes in total, and then the actual data, which is particle position data, and then finally the usage, which for us is gl static draw, and now I'm going to actually start explaining stuff. So if I Google for this function, gl buffer data, and the reason I'm using gl buffer data is because generate buffers and bind buffers doesn't give you that much information. Gl buffer data gives you most, and you can see it's got target, size, data, and usage. We can ignore this named buffer one because we're not using a named buffer, we're just simply using one of these ones. So the target specifies the target to which the buffer object is bound for gl buffer data, which must be one of the types of data in this table. Basically, I've actually read that wrong. GL array buffer is the one we're using, which is for vertex attributes, and if you remember from the last video what a vertex attribute is, then that's good, because then I don't have to explain it. But if you don't remember, then a vertex attribute, if I go back to the mesh class, x, y, and z position there, that's one vertex attribute, uv for the second vertex attribute. So that's what we're going to be using, the GL array buffer. And there's other buffers here as well. If you're not unsure what a buffer is, it's basically a selection of memory. And this says it's an array buffer. So that's basically a selection of memory to be used for a list or an array. And that's all that is. And then if we go down, we've got some other stuff going on. Let's see, draw indirect. No, we don't need that. Element array buffer is what we're using for the indices in the square last time. Query buffer, I don't know what that is. Shader storage buffer is really useful because we can then read and write data that's stored in the buffers in a compute shader. I think you can also do it in the vertex shader as well, but I'll go about, well, we'll use a shader storage buffer in the future tutorial about compute shaders. Transform feedback is an interesting one. Apparently it's really unintuitive, but I'll probably look into more into that when we're in the future. And then we've got a uniform buffer as well, and if you remember our uniforms, I don't think I've got them attached to this anymore, have I? But we had a uniform for the color and the uniform for the time in the last one, and a uniform for the position as well. You can actually assign those all to a buffer. So instead of setting a uniform every single call, like so you set a uniform for the time, and then you set a uniform for the position, and then you set another uniform. You can just set them all in one buffer, and that basically means that it's much cheaper to use, cheaper to call one function rather than call a similar function 3 times. I hope that made a bit of sense. Anyway, that's what buffers are. That's all the kind of stuff that's there. The size, like I said, the size in bytes, so we have to assign the size in bytes, otherwise we'll just not have enough data for this function. So if I was to get rid of this size of thing, so we only had 2,000 bytes available for this particle position data, first thing it will do is only assign the first 2,000 bytes of data to that buffer, but then also when we say the number of particles, it will come up with an error because there's not actually that much data in there. So we're going to leave the size of in there. And then we got the data, which actually means the data passed in, which is as simple as saying that particle position data. And then finally, the usage. Now you've got a few here: stream, draw, read and copy, static draw, read and copy, and dynamic draw, read and copy. We're going to use dynamic in a future video, but for now we're just using static, which basically means it gets modified once and then used loads. So for our one, that this here where we assign the data, where we pass the data to that to OpenGL, that's it then. That's never getting updated again. That's the static part. It's never updated. The dynamic basically means you can update the information in there. And with a shader, actually I won't go into too much detail. Then you've got draw, read and copy. I've used read and copy before. The funny thing is read, I've used that and drawn with it. But draw makes the most sense for what we're doing, so I'm just going to simply put static draw. So that's the buffer bound, and we bound the buffer, and we've got all the buffer data stored. I'm just going to quickly go through this bind buffer bit here. So after we've generated a buffer on the graphics memory, we've got a bit here where it says to bind a buffer, and we bind the GL array buffer, and then we have to say the GL array buffer here as well. But we can bind multiple buffers at the same time. If we were to have, like say we had a shader storage buffer and a element array buffer active at the same time, then OpenGL knows that if he's put the GL array buffer here, it needs to talk to the active GL array buffer, which is the particle position buffer in this bit. That's the reason we've got this kind of weird bit going on here. Otherwise, we could just activate one buffer and then just loop around. It wouldn't be as confusing, but for now this is the way it works. Okay, so we've done that. Let's do the vertex attributes now. So GL vertex attribute pointer, and this is going to be 0. The size is 2 because we've got 2 pieces of data for the X and Y position. It's kind of annoying because the size of the buffer needed to be in bytes, so that's strange. And then the type is GL float. Probably should do that as a thing here. There we go. And then the what's next? Is it type, size, type, normalized? Yeah, I'm on normalized now. This is false because the data's a position, not a direction. It might be interesting to change this to true once we're done, just to see what happens. And then the stride and pointer are really complicated, but we can just put 0, 0 because the data is tightly packed. There's nothing else in it. There's no other vertex attribute inside this data. If I go over to the mesh class, you can see that we've got 2 pieces of data per vertex in one line. And that's basically not tightly packed data. This is data that's packed in together. So we've got 2 pieces of data. In fact, I'll go down to the mesh class and explain it to you because it's a bit strange. So we've got the first 3 values, X, Y, and Z. And the thing is that the stride is the actual size of the data, so it has to be the size of a GL float, which is, I'll just put in here so it makes a bit more sense, times 5, and that's so 5 times the size of a float is 20 bytes, and then you've got the first 3 bytes, so the first 12 bytes are X, Y, and Z coordinates. So you're skipping over, well, so that's the size of the stride, and then on the end we've got the pointer to the actual bit. So for the X, Y, Z values, it doesn't matter too much because it can be 0, it can be 0, 1, 2, and then we have to skip over these 3 values to get to the last 2, which is actually 3 times 4 for 12, and then the last 8 bytes on the, oh my god, I'm not explaining this very well at all, am I? Maybe I should draw it. I'll tell you what, I'll draw it and come back. I have actually explained what a GL vertex attribute pointer is before, but there's the googled information if you want it, and you can always just Google it yourself. And I've drawn it. So we've got the offset, which is X, Y, and Z, which is actually 12 bytes, and then the UV data on the end is, why is it flashing up? Oh, well, UV data on the end, it has to be after a pointer, which is a pointer to the last value, the last 2 values. Oh my god. There we go. So the last 2 values have to skip over the first 3 values, which is 12 bytes, to get to the last 2 values, which is 8 bytes. Right. we don't need to even know that for this function. So let's just go on, carry on. I am very sorry about that because that was nasty. GL enable. Quick voiceover whilst I'm editing this. So this was nasty. I'm going to make another video on buffers and vertex attributes with diagrams on that, so it makes more sense. So don't worry too much if this bit was horrible like it actually is. Apologies for that. Array attribute, is that the right one? No, but oh well, this one will work. We want the particle object location, and it's 0 because it's the first vertex attribute. So I've got a feeling it's going to work now. We just need to bind buffer, the GL array buffer to 0, and unbind the vertex array object to that 0 as well. Now when we run this, fingers crossed, we've got a load of particles in a nice big old slopey line. Yes. That was a very big surprise, I'm afraid. Let's make this a bit more interesting. Minimizer times 2, and also in the actual main we're going to change a couple of things as well. So we want GL enable GL enable GL points, spelt badly as usual, GL point size equals 10, so that we can actually see the points. Let's see what it looks like. There we go, big old slopey line in a sine wave, in case you were wondering. Now I wanted to show you how this was modular, so if I go into here, I'm just going to go to the toolkit. I'm going to grab these, Control C, go to downloads, new folder. What should we name this? Particles class. I'm just going to copy paste them in there. I'm going to delete this. Oh, actually, I won't be able to delete it yet because it's open there. And it's going to be well, Visual Studio does stuff in the background when you close something down. So I'm going to pause while I'm waiting for this to delete. Right, it managed to delete. So if I get the template again, extract here. Oh god, I extracted to script. Extract here. Yes to all. Right, rewrite all. I don't give a shit. Where's it gone? Extract here. What? Where's it disappeared to? Oh, apparently it's last week. Oh my god, what is going on? Right, delete, extract here. There we go. Now it exists again. Oh god. I'm going to copy these two. So right click and copy. Doesn't matter what if you do Control C or whatnot. Go to the template master. I'm going to put it in the toolkit project. Go back. Oh, open up the README because I'm a bumhole. I'm really sorry about being so dumb sometimes. Let's see. 64-bit. Change this to 86. Go down to here. Source files. OpenGL toolkit. Include the particles.h. Underneath here, just put same as we did before, particles dot create particles. I kind of want this to be, oh, we need 1,000 in there. I'm going to set this to 10,000 just to see if it's any different. And we also need to do the GL point size stuff, or we won't be able to see them that well. So GL enable GL points. GL point size is 10, so we can see them. Got create particles there. I'm going to comment out the triangle. Actually, I'll leave it in there. Why not? Particles dot render, and then we'll see what it looks like. Should just be a blue wave behind the triangle, but we'll find out. Oops, what have we done? Create particles unsigned in, referenced in main function. It's not supposed to have any problems. I've never had it had problems before. Oh, I'll tell you what. It's because I've not added the thing. So add existing items. Then we want to add particles.h and particles.cpp because the particles.h won't be able to read the particles.cpp from where it is, or this particles.cpp won't be talked to a tool to talk to particles.h. So that's fixed now. If I run it, there we go. We've got the blue kind of triangle wavy lines. I wonder if it'll be I'll tell you what, let's animate this a bit, and I'll get rid of the mesh. Get rid of the mesh. We're using the template. Sorry, you got my maths homework. Shaders. What we're using this one. Open this out. This is actually a vector 2 now. We can leave it as a vector 3 because it doesn't seem to have a problem, so I'm going to leave it. I'm going to add a uniform in there. Uniform time, because I love uniform time. And then we've got apos here, but I kind of want to edit this. So let's make a vector 3 called position equals apos. Oops. Apos. And then apos dot y equals sign time plus apos dot y. Some of you may have figured out what this is going to look like. This is supposed to be position anyway. Like position dot y. And then we can simply put this here, and we need to set the time uniform. So underneath here, shader dot set uniform 1f time glfw get time. One of the main things you'll see in shaders is time, because it's such a good way of animating stuff. It's so much easier than using transform feedback or anything like that. Got a problem. What is it? Vert shader, fourth line. Oh, I bet I've not put float. I always forget to put float. Come on. Why is it all white? There we go. Now we got what was going on there. Oh, that's exactly what I expected to happen, but it doesn't look right because for some reason points isn't changing the size of the points. Oh, point size 10. I'll tell you what. Let's make this a bit more interesting. We don't want geo points. Whoa, what? Oh, I must have left that in from before. So I'm going to get rid of that. I'm going to duplicate this. GL point size. Is it program? GL pro. Oh, come on, GL program point size. There we go. And that means we can control the size of the points inside the shader. So if we say GL point size equals, let's say 10 times. Now the thing is, we want a particle position. Let's say apos dot x plus 0. Plus 1.0. I'm probably change this to 5 as well, because it's going to go from 0 to 2 across the screen. So it should be kind of like a wave that gets bigger as it gets to the right, if that makes sense. Like thicker on the right. Yeah, there we go. Thicker on the right. So, yeah, fun stuff. Nothing amazing, but let's add a bit more variety to it before I finish. So we're going to go to particles.h. We've got the create particles function there. Let's go to that. And the y value, I kind of want... Yeah, okay, so we search C++ random, because I've not used random yet, and I feel like we should. This is my cheating way of getting a random value, so we're just going to literally copy this, paste it here, and we've got a value between 1 and 6. Let's make this, we need to make this negative, the number of particles, which has to be of type integer. So I'm going to change this to an int, because it's an unsigned integer, and unsigned integers can't go below a certain number, can't go below 0. So converting it to an integer means it will go below 0. And then we got this dice roll thing. We can get rid of all that. Get rid of that. In fact, just get rid of this line. Makes more sense. And then I kind of want to add... Yeah, so we'll say... how should we do this? Particle. Right, so plus distribution generator. So this is going to generate an integer between negative number of particles and positive number of particles, and we want that to be a float. So I'm going to convert this to a float. This is really backwards way of coding, by the way. I don't recommend you do it this way. It's very weird. Let's make this times minimizer divided by, let's say, because it's going to go, the minimizer divided by 2 makes it between -1 and +1. So what if we make it, minus 1 and positive 1 seems a bit too much, doesn't it? So divided by 20. Let's see what this looks like. It might be a complete break, but we'll find out. That looks a bit more like well, something more interesting than I expected. We could always animate the color as well, but I think I'm going to leave it there because this video is probably 40-50 minutes maybe. Anyway, I hope you enjoyed, and I'll see you next time.